Hello everyone, my name is Eric. I'm from the University of Toronto and I'm here to present my work, which is titled Investigation of Remote Work for Aerospace Systems Engineers. So some introductions. To be clear, this recording has no video, just audio to make sure that the full slide is visible for everyone. But this is me. I've recently completed my bachelor's degree at U of T in aerospace engineering, and I'm in the fall going to begin my master's degree also at U of T in the Spaceflight Laboratory. My supervisor is Dr. Alison Olejowski. She's also the co-author of this work with me, and she's an assistant professor in the Department of Mechanical and Industrial Engineering at the University of Toronto, and she's the principal investigator for her lab group, which is called Ready Lab. So I wanted to start by unpacking the title of this work. So first of all, remote work, what is that? That's essentially what we've all been doing recently in the past year and a half or so as a result of the COVID-19 pandemic. You're watching this video recording, and I'm recording this from my home. That's a form of remote work. Or if you are watching this presentation live at the INCOSE conference, that's also another form of remote work because we're on a Zoom call together and not in the same space. The opposite of remote work is co-located work, and that would be if I was presenting this to you in person in the same room as you. And there's a few other words to refer to remote work, which is virtual work, working from home, or a more dated one, which is telework. So the other aspect of this study is aerospace systems engineers. So who are aerospace systems engineers and what do they do? So these are the engineers that essentially work on the things you see here on the right. So aircraft, spacecraft, rockets. The engineering and creation of these types of systems is extremely challenging, very complex. These projects often take many years or sometimes decades to complete, and the collaboration is between many organizations, sometimes whole nations. And of course, there's several established development processes to develop such systems. One example is the NASA Systems Engineering Handbook, which we're going to talk a lot about in this presentation. So when combining remote work and aerospace systems engineering, there's something of a research gap here, which has led to kind of this study. So the research gap arises when you realize this study is a combination of three aspects, which is aerospace engineering, systems engineering, and remote work. So each of these fields individually is well studied, but in combination, there are some significant gaps in the literature, and let's unpack that a little bit. So starting off individually, first of all, remote work. This is a very well studied field. There's a literature review from 2020 that covers the field of remote work, particularly for teams, really, really well, and this is probably the last literature review that will have come out in literature before the COVID-19 pandemic. And after which I would expect there to be some sort of shift or transition in the study of remote work. The other aspect is aerospace engineering. Not much to say here. This is an entire engineering industry and discipline on its own. And then, of course, systems engineering. We're all at a systems engineering conference. And so, an excellent example of systems engineering literature is INCOSE's Systems Engineering Handbook. So when it comes to combining these different fields, the intersection of remote work and aerospace engineering, not very well studied. There are some studies on remote work for engineers in general, which is this Loom-Safei paper from 2019. So that's a great paper, but it doesn't necessarily target aerospace engineers, and there's not much out there that targets aerospace engineers working remotely. When it comes to remote work with systems engineering, this is a really limited area. There's, I think, one paper on the subject by Harris in 2001, and this was really more of a passing mention of the intersection of remote work and systems engineering as opposed to a direct study on it. And of course, that's 20 years out of date now. And then finally, we have the intersection of aerospace engineering and systems engineering, extremely well established. The NASA Systems Engineering Handbook is a great example of this, or Fortescue's book, which is Spacecraft Systems Engineering, and of course, there's many other resources out there. So combining these intersections and fields led to the research gap. And in order to study this, I generated 4 different hypotheses to explore. And so we're looking at the first hypothesis here. And the first hypothesis is that design reviews will experience challenges to remote work. So what's a design review? Well, in the aerospace systems engineering development process, according to the NASA Systems Engineering Handbook, it can be broken down into phases. And so these are the phases you see here, starting from pre-phase A all the way to phase E. And so this essentially takes you from a conceptual design of a system, like an aircraft or a spacecraft, all the way through to the construction, launch, and operation of that aircraft or spacecraft. And these are the phases. So the type of work being done by aerospace systems engineers varies by phase, of course. And design reviews are important checkpoints basically between each phase. And so a design review has to be successful in order for a project to be given the green light to move forward to the next phase of work, eventually to completion. And so the first hypothesis here is that design reviews, which are very important for systems engineering work in aerospace, will experience a lot of challenges due to remote work. The next hypothesis has to do with artifacts. So an artifact is essentially a representation of work done, and I have a definition here. But you can imagine an artifact as anything like a PowerPoint presentation, a Word document, a report, an Excel spreadsheet, a project timeline. It can even be a finite element simulation like this or a CAD model like this. So of course, artifacts are very extremely widely. And so a change from co-located to remote work, we might expect there to be some issues with artifacts and some changes going on there. And so that is indeed the second hypothesis. The third hypothesis has to do with AIT. So AIT stands for Assembly, Integration, and Test. And it's the activities that take place essentially in phase C and phase D of these life cycles. And it has to do with basically putting the parts together, integrating all the different subsystems, and then doing final tests before actually sending the vehicle into operation. So assembly, integration, testing activities, especially for very complex systems, require very complex facilities and specialized hardware, and sometimes things like clean rooms and other stuff like that. And so because of the complexity of doing AIT and the fact that a lot of it's co-located, in-person work, we'd expect there to be some challenges when trying to do this in a remote work scenario. So the final hypothesis has to do with solutions. So for some context, the restrictions due to the global pandemic began in Canada around March, back here. This is March of 2020. The study began with interviews in October of 2020 and ran through here. And of course, now here we are all the way in July of 2021, and I'm presenting this work. So big timeline there. And the point of this slide is to point out that there's a big gap of time between when kind of remote work started in Canada and when this study started. And so in that time, we'd expect that the engineers working in industry would have come up with a number of solutions to the challenges they face. And so this is, in fact, the fourth hypothesis, to look for these solutions to see what strategies exist and what they've come up with in the time. So to summarize all these hypotheses, this is a diagram I've created, and essentially breaks down the concept of the research questions down into the theory and into the hypotheses. So we started asking, what is the impact of remote work on industry for engineers? Particularly, what about the systems engineering process, which led us to design reviews, artifacts, and assembly, integration, and testing for 3 hypotheses. Then the question was, what are some possible solutions that have been come up with? That's the 4th hypothesis. And then, of course, there's this aspect of what are some unexpected issues, so things that we're not capturing in these hypotheses, which we can capture in additional analysis. So how does one go about studying these kind of hypotheses? And the answer is qualitative methods. So qualitative methods are kind of in contrast to quantitative methods, and they work really well when there's a new and poorly understood phenomena. So an example is with a typical quantitative study, you might create a survey with some set questions, and people who are responding to your survey can answer yes or no or rate the responses on a scale of 1 to 10. And you could send this out to a large sample, maybe several hundred people, get back, run some statistical analysis on it, and see the results and the statistics to do that. Qualitative methods are kind of the exact opposite of that and are designed when you can't, they're preferred when you can't really give a survey because you don't know the correct questions to ask in the first place. So a qualitative methods are text-based. They're based on being able to explore beyond the original hypotheses, beyond the original questions you have. They're focused really on individual lived experiences. They really aim for depth first, and of course, they're very small sample size. And so qualitative is not numerical statistical, like I said, it's not quantitative. Qualitative is very well suited for not well suited for claims about populations because of the small sample size, and it doesn't do very well with randomized sampling. Often there's a snowball effect, and so you end up collecting groups of people who are kind of related to one another. So randomized sampling doesn't work so well for qualitative methods. And so there, of course, there's some drawbacks to qualitative methods, but they function really well for this study. So how the study was done started with interviews. There were 6 participants interviewed. They were actively employed at a single aerospace engineering company here in Canada, all of them aerospace systems engineers, and working remotely for many months before the start of the study. The interviews were semi-structured, which means I went in with an initial set of questions to ask, but often deviated from that list of questions to explore new and interesting ideas that the participants were bringing up that I hadn't thought about in advance. So great perk of using qualitative methods there. So the next step was transcription, which involves taking these recorded interviews and transcribing them into a text document. And the analysis is done on the interview transcripts. So to give you an idea of how much data is involved with the interview transcripts for 6 interviews, each transcript is about 10,000 words for an hour-long conversation. And so for 6, that's about 60,000 words. I probably read through these transcripts about 3 times total, once just to make sure that the transcription was clean and done properly, another time to go through and do the actual coding process, which I may mention in a second, and probably a third time to go back and recode and look for quotes and all that. And so that means I've probably read about 180,000 words, which is about the same length as the Fellowship of the Ring book. So quite a bit of data there. So once you have the transcripts, the next thing to do is coding. And so coding the transcripts was done using this NVivo software, which is very powerful. And it essentially lets the researcher categorize statements made by participants and organize those into what's called nodes. And so I created several nodes based on the hypotheses that I've just gone over, and looked at what participants had to say about each hypothesis to see kind of what are the results for each hypothesis. And then, of course, looking for other trends and patterns beyond the original hypotheses. So going into the demographics of who I interviewed, there were 6 participants, of which only 1 was a woman, and the other 5 were men. Of the 6 participants, 3 consider themselves pure systems engineers. 1 is a mechanical engineer, 1 is a software engineer, and 1 is a computer engineer. By seniority, we have a really skewed data set towards only senior participants. So this is the order of seniority. So we have junior, intermediate, and engineer participants. There's none in our study. There's 5 senior participants and then 1 staff, which is kind of more quote-unquote senior than the senior position. What this does create is a large number of years of experience. So all our participants, the sum total, they have 78 years of cumulative experience at this one aerospace engineering company, which is a lot of time they've spent there. So a lot of interesting insight came from this. So what are the results? Starting with the first hypothesis, here we see a quote from one of the participants. So like I mentioned, this was an interview-based study, and so there's throughout this results section, there's many quotes from participants, and this is one of them. So I'll give you a moment to read that. And so here the participant was really just expressing to us how they appreciated this study. They were really engaged and willing to help us along and provide their perspectives and insight. And they were happy generally that someone was paying attention to this aspect of their work. A little bit of actual background and context before we jump into the results. So remote work for this company is new as of 2020. The company we interviewed had never done remote work before this. They had a very on-site mentality. And so typically they were all on-site and all co-located in the office space. When things transitioned to remote work with this onset of the pandemic in mid-2020 in Canada here, 80 to 95% of the workforce was remote, which basically meant working from home, although this fluctuated somewhat. And something to note here is that working from home is not a very uniform experience. So photos you see here on the right are home work setups for 3 different participants. And as you can see, 3 very different realities of what working every day looks like. So starting with the first hypothesis, design reviews. It was found that there are both benefits and challenges to conducting design reviews remotely. So of the 6 participants, 5 were part of design reviews. I believe there was 2 different design reviews they mentioned. And so at the design reviews, they basically said, there was no major downsides. And there was a system that was implemented for these design reviews to be conducted, and that was used for both of them, and it seemed to function quite well. And so that involved having a small group of core facilitators in the office space, and they were running kind of a Zoom session for the 50 some odd people that were part of the design review. And then internal to the company and not with the customer at the design review, there was a Slack channel used to communicate and generally keep people interested and inspired. And so we'll talk about Slack a little bit later in this presentation. So there are three key benefits highlighted by the participants for design reviews done remotely. First of all, there's no need to travel. So you don't need to pay and worry about accommodations and flights and all that. And there's cost associated with that, and there's also time benefits associated with that. And one of the benefits from that is that more people from the company could attend than might otherwise be possible if everyone had to book a flight to fly to wherever this design review was. Another benefit is that those just observing the design review can kind of not focus on it and work on other tasks without disrupting the people in the design review. And finally, the design reviews, because they were just in a Zoom session, they can be recorded quite easily, and so that makes taking minutes and going back and understanding customers' questions very easy to do. So there are some challenges associated with design reviews as well. And these were basically highlighted as components that are missing when compared to in-person events. So I don't know if I mentioned this, but videos for most individuals is off. So there's not a lot of facial expression, visual cues, and of course there's no opportunity to meet face-to-face with a customer. So there was a lot, that aspect was really lost. This is a quote from one of the participants, basically explaining how important communication and visual cues are when doing the design reviews. So something I mentioned, which is relationships. So this pre-established relationships and rapport is very important. Some of the participants at these design reviews had worked with the customer before the start of remote work, and they really emphasized that having that pre-existing relationship was very helpful when moving to a remote collaborative setting. When it comes to the future design reviews, based on this finding, we would suggest that design reviews in the early phases of the project, so phase A, phase B, be co-located as much as possible to establish that initial relationship between the client and customer. And after that, the design reviews could probably shift to remote because that relationship has been established, and that will make working remotely with one another easier. Okay, so moving on to the second hypothesis, artifacts. So the findings were artifacts are not quite straightforward. There are a few things to note here. So first of all, there's some aspects of artifacts that have not changed. So the artifacts that are created and how they're created have not changed. Most artifacts are computer-based. And so I think we all can understand this. If you're working on a PowerPoint presentation, a Word document, an Excel document, or even a CAD model, all that is on a computer and can be done equally as well in the office or at home. And so remote work doesn't really impact the creation and use of those artifacts. It was also found that there's no new artifacts created for remote work. So apparently there was no need to create additional documentation to support the engineering process. And that was all taken care of and sufficient with the existing artifacts. There was no need for new ones. This is just a quote from one of the participants. So there are some challenges with the existing artifacts when moving to remote work. So printing out large size mechanical drawings was highlighted as one issue. Another one was some latency when doing a remote desktop from home to a computer in the office running a heavy duty CAD software package. That was noted to be kind of slow. So the other aspect that has changed with artifacts is collaboration. So a lot of the artifacts participants work on collaboratively, and they like to sit with each other at a desk and go through them together. And that's much more difficult when working remotely. And in fact, one of the big issues was the time aspect. It takes much longer to reach out and get a hold of someone to work on an artifact when doing that remotely. So this is just a quote describing the importance of collaboration and working remotely. So essentially the source of the slowed communication is that you now need to book a meeting with someone or get a hold of them via some communication method as opposed to just walking over and talking to them at their desk. And so this kind of slows the process of artifact creation down. There's also limitations of tools. So some of the tools do not provide super great collaborative aspects. And so like one of the examples that was highlighted was in Microsoft Word documents, you can do these track changes, which is where it's clear that there's comments and edits made by someone else, but you can't do the same thing in a spreadsheet. So that was a limitation. A final limitation I'll mention is that certain communication platforms are restricted by the need for aerospace data to remain secure, and so you can't send certain aerospace related project data over some communication platforms because it's just like not allowed and the data is restricted. Okay, so the third hypothesis has to do with AIT. So the results in this area, essentially AIT has had a lot of difficulty with remote work. Something to note about this company is that there is still assembly integration and testing going on in the building, but the on-site activity was limited. So that 95% of the workforce was working remotely means that 5% was still in the office. And so 5% in the building, those were often technicians who were working with hardware and doing things you simply cannot do from home. And so the participants we interviewed are all engineers, and so they were primarily remote, while a small number of technicians were on site. So a lot of the challenges to do with AIT are focused on how difficult it is to communicate about physical hardware when talking to someone remotely. And so this is a quote from one participant who's describing how difficult it is to translate the experience of working with hardware on the shop floor setting, working with others, to Zoom. And here you can say they basically say that to share all the different kind of references you're using when you're working with hardware on the shop floor via Zoom is just not possible. And in a similar vein, communication about hardware with external suppliers, so the suppliers that create hardware parts, was noted to be very difficult. No longer could the company we interviewed visit suppliers in person before production to explain the parts they were to produce, and they could also not go inspect the hardware before the final shipment. And so this led to some issues. So here we have one participant explaining there's been big glaring errors that made it through the chain, which is the supplying order system, because they weren't allowed to inspect on site. So finally, looking at the final hypothesis, which was to do with solutions, what are some possible solutions? We found a few. So first one is Slack. So Slack is a platform for organized instant messaging. You can talk in channels where multiple people are present and everyone can see the messages, or you can talk to people one-on-one. And it's really meant for workspaces and is designed to kind of help organize a large amount of communication while making communication with other people very easy. And so indeed, our participants said this type of communication was great for the systems engineering work. It was quick and informal, and it was very efficient. But there's some downsides as well. So Slack, they said, does not provide records in the same way that email does, because with an email, you might have a nice clean chain leading to a final engineering decision, whereas with a Slack channel, things can be kind of all over the place, and you have these really long conversations of messages back and forth, as if, in the same way that people text one another. Another big drawback, which I already mentioned, is that Slack is one of those platforms you cannot send secured aerospace data on because Slack's servers were not located in Canada, where this company is, and the servers were not set as known to be secure for holding that data. And so participants had to still send data by email or other methods, and so Slack's use for that kind of dropped, which led to some challenges. One final aspect is there is a disparity in the adoption of Slack. So not everyone at the company liked or used Slack. And so some people really liked it while others didn't use it at all. And so it became a bit frustrating for people because Slack, I think, does work a lot better when everyone is on board and everyone is on the platform. So another solution we found is that managers should limit meeting frequency. So we found two suggestions for managers, and this is the first one. Basically, participants noticed that they're scheduled to attend more meetings during remote work, just because the only way to contact people is to be on calls with them, and so they're constantly being booked up with calls. And so one strategy that we found in the study is for managers to reduce the number of meetings that they book for their participants to kind of pre-remote work levels. And this is really done to let people have time in their day to focus on work and not be stuck in calls all the time. And so we see one participant explaining that here. This is a manager. So the final solution we found, which is related to the first, is managers should host regular office hours on video or conference calls. And so this is basically intended to provide team members with the time to talk to their manager or have side discussions with their team members. But the idea of office hours is that it's not mandatory. Anyone can join at any time, but no one has to join at any time. And so the manager who implemented this found this was very effective. Here's what they say. And the idea was basically to emulate the informal side conversations that occur in the office. Great, so that's all the results for this study. And so now I want to talk about kind of the future work. And so part of the nature of a qualitative study when you interview people is you get a lot of areas for future work, and it really opens up future possibilities for studies. And so that was indeed the case with this study. So first of all, some simple areas for future work. Improving the diversity of the sample was a big area. You might have noticed the gender balance in the study is very off. There's only 1 woman and 5 men. The sample size is very small. There's only 1 company, and of course the engineering disciplines that we studied is limited. Also, we did not uniformly represent the project life cycles, which is that phase A, phase B, in our participants. Extending a qualitative study to quantitative work is a pretty straightforward approach, and so confirming these hypotheses in a measurable way would be great. Another thing to note is that this study kind of investigated the near-term impacts of remote work, like 7 or 8 months into remote work, as opposed to like 3 to 5 years into remote work. So we really looked at kind of the post-transition into remote work as opposed to the we've been in remote work for many years kind of situation. And so there's a question there, but what does that look like and how did things change? Something else we found is that there's a need for alternatives to traditional whiteboards. Some of the participants expressed that they didn't have good whiteboarding tools available. So relationships is another big area. We found that kind of in remote work, relationships play a very big role, and sometimes even a bigger role than in co-located work. When it comes to design reviews, teams with existing relationships with the customer seem to do better, and so that would be something worth looking into. And then general relationship building during remote work is also of interest. And so here's a quote from one of our participants. Okay, so then there's hardware work. So I mentioned AIT had challenges with hardware. This raises a question of what are some existing or novel solutions to kind of communicate about hardware remotely and inspect hardware for supply chain concerns. And then, of course, there's communication platforms. So why was Slack adopted differently throughout the company is another question to ask. And then, of course, just generally with communication and remote work, this is kind of a big area. And in fact, the literature does cover this in some respects. And so, here's a quote from one of our participants highlighting the importance of communication when it comes to systems engineering. Okay, so then there's this last aspect, which is there's a disparity in the sentiment of remote work. So sentiment meaning how much people like or dislike remote work. And because remote work was new to this company, some participants found it a new and interesting and positive experience, while others did not like it. So here's 2 different perspectives by participants we interviewed on remote work in these quotes here. So future work in this area could really look at what factors contribute to personal sentiment on remote work, and why does that vary? So that concludes the presentation. I'd just like to take a minute to thank people for the support. So first of all, my supervisor, Dr. Allison Oliowski, was very supportive for me in this project. There's also the iLead organization, which is part of U of T, that made this connection with industry possible. And finally, everyone at Dr. Oliowski's lab, Ready Lab, has been very supportive of me with this research. So in a live presentation, I would now be happy to take questions. If you're watching this recorded, and you have some way to reach out, feel free to reach out and ask questions. Thank you very much.